Good afternoon, dear students. Yes, so in the previous class, we have started with the new chapter, that is chemical kinetics. Okay, so in the last class, we have discussed what is the chemical kinetics, right? Then we have discussed about the rate of reaction. So what is rate of reaction? So different type of rate of reaction. Okay, it can undergo like chemical reactions. They can undergo fast reactions, slow reaction, and moderately slow reactions. Right. So this we have seen. Then what is the rate of reaction? So this rate of reaction, it is classified into two: average rate and instantaneous rate of reaction. Okay. So we have discussed about this also. What is the average rate and how do we calculate the instantaneous rate of the reaction, right? So we know how to write now for how to write the expression for rate of reaction, right? So we have seen that also. So in the last class we had solved one problem, right? So based on the rate laws, okay. So based on the rate equations, so let us solve few more questions, okay. Then we will start with the factors, okay. So two more questions. So let us see. So the second question is, in a reaction, okay, to A giving you a product, okay, the concentration of A decreases decreases from 0.5 mole per liter to 0.4 mole per liter in 10 minutes. In 10 minutes. Okay. Calculate the rate. Calculate the rate during this time interval. During this time interval. Okay. So can you calculate? Yes. So firstly, how to calculate the change in concentration? So change in concentration is nothing but delta R, right? Concentration of R. The change is from 0.4 to 0.5, right? So so it is off from 0.5 to 0.4. So it is 0.4 minus 0.5, that is minus 0.1 mole per liter, right? Now what is the time taken? Time taken is given as how much? Time taken is 10 minutes, right? It is 10 minutes, right? So now what we have to find? We have to find the average rate. So how to calculate the average rate? So average rate is equals to, so it is 2A giving you product. So average rate is what? 1 by 2. Okay. Then change in concentration of A with respect to time. Okay. So average rate of the concentration of A. So how to calculate? So it will be minus half delta A by delta T. So minus half. So change in concentration is minus 0.1 upon what is the this? It is 10. Okay. Time taken is 10. So calculate how much it is. Just see. So this will be 0, minus of minus will be plus 0.1 divided by 20. See how much I'm getting? 0.1 divided by 20. So it is 0.005 mole per liter per minute, right? Because this is minutes, in minutes, right? So this, when it goes up in the numerator, it will become per minute. So the answer is 0.05 mole per liter per minute. Yes, good, very good. Yes, Sri Varuni and Bibi has got it correct. Very good. Okay. Let us go for the next problem, one more problem. So the decomposition of N2O5 takes place according to the equation 2N2O5 giving you 4NO2 plus O2. Okay, so the decomposition of N2O2 takes place according to this equation, that is N2O2 gives you 4NO2 plus O2. The initial concentration of N2O5 is given as is 2.33 mole per liter. Okay, and after 184 seconds, it is reduced to 2.08 mole per liter. Okay, so what you need to calculate, you have to calculate the average rate, calculate the average rate of this reaction in seconds, minutes, and hours. Okay, so what is the rate? What is the rate of production? What is the rate of production of NO2 during this period? So this is the question given. Okay. So the question is that so the decomposition of N2O2 is taking place according to N2O2 will give you 4NO2 plus O2. So the initial concentration of N2O2 is given, which is 2.33 mole per liter. And after some time, that is after 184 seconds, the concentration is reduced to 2.08. Okay. So you have to, so the change in concentration is given, that is 2.08 minus 2.33. So you have to calculate the average rate for this reaction in seconds, minutes, and hours. And what is the rate of production? So how much NO2 is produced during this period of time? So from this reaction, okay, so the reaction is given. So this is the reaction 2N2O2 plus 4NO2 plus O2. So what is the rate of reaction? So for first write the rate of reaction. So the rate of reaction is equals to, so that is change in concentration of the reactant. So that is minus half rate of concentration of N2O2, N2O5 divided by time. Okay, so how much it is? Calculate. So this will be half change in concentration of this is 2.08 minus 2.33. Okay, and the time taken is 184 seconds. Okay, so this is second and this is mole per liter. Now this calculate, just see how much you'll get. Yes, first you find the this difference. Okay, take first 2.08 minus 2.33. So that I'm getting minus 0.58. So minus of this is plus. So this becomes plus 0.58. Then 2 into 184. It becomes 368. So 0.58 divided by 368. It is 0. How much are getting? Just see 0.0015. Why you have that what different? Let us see again. Hmm. 08 minus 2.33 minus 0.25. 2.33. It is coming minus 0.25, not 58. Okay, here it is coming 25. How much again? 2.08 minus 2.33 is minus 0.25. Okay, so this is C now minus 2.05. So plus 0.2525 divided by 368. Now you see, it's not, yeah, it is not 0.58, it is 0. Yes, very good. Okay, so now you are getting it. Yes, very good. So it is 0.25. Okay. So how much you will get here? You will get, so it is 0. Okay. I have got how much? I have got 0. 0.000679. So if I shift the decimal, okay, 1, 2, 3, 4. So it will be 6.79 into 10 raised to minus 4 mole per liter per second. Okay, so this is the rate of the reaction. I hope you have got it. Right. Now, what you have to, this is the rate of reaction, right? Now we have to find the rate of reaction per, okay, rate of the reaction per minute. So let me clear this. Okay, so let me clear the question about. Okay, so let me clear this. So now, what is the next step? The next step is you have to find the rate of reaction per minute. Okay, so how to calculate that now? The rate of the reaction per minute. So now, rate of reaction in per minute, in per minute. Okay, so how to calculate? So rate is equals to 6.79 into 10 raised to minus 4. Okay. Mole per liter and second into per minute is 60 seconds. Okay. 60 seconds is 1 minute. So second and second get cancelled. So rate is what? Rate is equals to. So if you calculate this, so calculate now 6.79 into 60. It is 407. Okay, 407 into 10 raised to minus 4 mole per liter and per minute. So this is in terms of per minute. Okay. Now what we have to find? Now we have to find rate of reaction, rate of reaction in per hour, per hour. Okay, let us find this now. How to calculate? So rate is equals to, okay, so per hour, so per minute. So let us take, okay, so in minutes, so we know that 1 hour is equals to 60 minutes. Okay, so we can calculate, so 107 into 10 raised to minus 4. Okay, a mole per liter and per minute into, okay, what is per hour? 60 minutes. So 60 minute per hour. So minute and minute get cancelled. Okay, so minute and minute get cancelled, not per minute. So it will be minute only. So it get cancelled. What you will get? You will get R is equals to. So calculate now. 407 into 60. 407 into 60 is 24420. Okay, into 10 raised to minus 4 mole per liter hour, per hour. Okay, got it? Yes. So next is per second. So 1 minute is equals to 60 seconds. Right. So let us do that. Next is, okay, so rate. So from this, so we have got the rate of the reaction. Okay, per second we have got. So we have got rate of the reaction per second first only. So this is the rate of reaction per second, that is 6.79 into 10 raised to minus 4. Then we have got rate of the reaction per hour and per minute. Then last, this was what you have to find. What is the rate of production of NO2 during this period? So how much this is produced? Okay, NO2 is produced. So rate of reaction is equals to, okay, so how much it was? So right, remember the equation was 2N2O5 giving you 4NO2 plus O2. Okay, from this, so what it is, 1 by 4 delta, okay, change in concentration of NO2 by delta T. Okay, so it is minus 1 by 4. So here, so what we can see here, that is Okay, change in NO2 by delta T is equals to 4 into rate of reaction. Okay, 4 times rate of reaction. So what is rate of reaction? So 4 into 6.79 into 10 raised to minus 4 mole per liter per second. Okay, so calculate now how much it is produced. Just see how much it is produced. So 4 into 6.79. So 27.16 into 10 raised to minus 4 mole per liter per second. So this is the concentration of, okay. Yes, very good. Yes. So your answers are correct. Yes. Okay. So like this, the problem can be asked. Got it? Okay. So this completes the problems on average rate. Okay. So now let us start with the factors affecting the rate of reaction. So what are the factors that are affecting the rate of reaction? So for your syllabus, what are the important factors? So we'll study that much only. Concentration of reactant. So the rate of reaction, it depends on, okay, so rate of reaction depends upon, okay, it depends on what? It depends upon the concentration of reactant. It depends on temperature. It depends on what? Depends upon the catalyst, okay, and nature of the reactants. Okay, so this much is there for your syllabus. Okay, so we'll produce only will discuss on this. So what are the factors which are affecting the rate of reaction? Concentration of reactant, temperature, okay, then nature of the reactant and catalyst, okay, and catalyst. So these are the four important factors which will affect the rate of reaction. So please note it down. So which is the factors which are affecting the rate of reaction is concentration of reactants, temperature, nature of the reactant and catalyst. Okay, so these are the four factors which will affect the rate of reaction. So first, let us start with the effect of concentration of rate of reaction. Okay, what is the effect of concentration on the rate of reaction? Suppose, so what is the rate law? There's something called as rate law. Okay, so there is something called as rate law or rate expression, or it is called as a rate constant. Okay, so there's something called as what? Rate law, rate constant or rate expression. Now here, so according to the rate law, okay, what is this rate law? According to the rate law, the rate of the reaction is represented mathematically, okay, with a mathematical expression and which gives through rate of reaction. So how is the reaction considered? Suppose let us consider A plus B giving you product. Okay. So let this be the general equation. So if we consider this general equation, then how do we write the rate expression for this? So rate expression is given as rate is directly proportional to concentration of A, okay, and concentration of B. So it can be x raised to this and it raised to y. So what is this x and y? X and y, okay, they may or may not be equal to psychometric coefficient A and B. So what is x and y? X and y, it is may or may not be equal to psychometric ratio x and y. So rate will be given as k into a in raised to x and b raised to y. So that is how is rate given minus d of r with respect to dt is equals to k into a raised to x and b raised to y. So this is the rate equation given us. So this is this equation, it is called as differential rate equation. Why we are taking dr by dt? Right, we are taking dr by dt. So whenever, so it is a differential rate expression and the constant k, right? You can see this constant k. This is the rate constant. It is called as what? It is called as the rate constant, or it is also called as the velocity constant. Okay, it is also called as a velocity constant or specific reaction rate, or it is called as what? Specific reaction rate. So the rate law is what? What is the rate law? So the rate law, it is the expression in which rate of the reaction is given in terms of molar concentration of reactant, such that each concentration term is raised to the power which may or may not be equal to its psychometric coefficient of reactants in a balanced equation. Okay, so this is the rate law expression. So what is rate law? So rate law is what? It is defined as the rate of reaction when its molar concentration of reactants is equal. It may be or may not be equal to its psychometric coefficient. Okay, so here, so here you can see. Okay, so it is given as, so if A and B, if the concentration is equal to 1, then what will be rate of equation? Rate of equation will be equal to the rate constant. Okay, it will be equal to the rate constant. So rate law for any reaction is equal, it is always determined experimentally. Okay, it is always determined experimentally. So this is about the what it is about the rate of the reaction. So this effect of concentration plays a important role in the affecting the rate of the reaction. Okay, so rate is directly proportional to what? Rate of the reaction. So we have seen just now, right? So what we have seen, so if we consider a reaction, okay, so what we have seen, if we consider a reaction A plus A, okay, okay, you can see here, if A plus B giving you, okay, AB, okay, then our rate will be given as what? Minus dr by dt. Okay, so minus dr by dt, it is what? So this is a rate which is directly proportional to concentration of A and concentration of B. So rate is equals to minus dr by dt. Okay, if we remove this proportionality sign, so I will introduce a constant, that is K, that is A into concentration of molar concentration of B. So suppose if A and B is equal, okay, if the molar concentration of A and B is equal, if we take it as 1, then rate will be equal to the rate constant. Okay, so I say that, so the concentration of the reactants, okay, concentration of the reactants will depend on what? It depends upon the molar concentration. So rate of the reaction is directly proportional to concentration of the reactant. So rate of the reaction is what? It is directly proportional to concentration of the reaction. Okay. So this is with respect to concentration, how it affects. Next is what? Next is the nature of reactant. Okay, let us take next one, nature of reactant. So the reactivity of a substance is related to the ease with which its specific bonds are broken and the number of bonds broken and new bonds are formed to form the product. So it depends on what? It is related to how specifically the bonds can be broken. Okay, or how many bonds are broken to form the new bonds with that is which are formed to form the product. So suppose and reaction is undergoing where it is undergoing oxidation. So NO, when it reacts with O2, giving you 2NO2. Okay. So this is a fast reaction. One more reaction where you can see that your carbon monoxide reacts with oxygen to give you carbon dioxide. Okay. So the rate of the reactants and the product, it depends on the specific bond breaking and making of bonds. Okay, so this is about your nature of reactants. Okay, next is the catalyst. Next is what? Catalyst. So how does the catalyst play an important role? So catalyst, it will influence, okay, either it will increase or decrease the rate of reaction without undergoing any chemical change. We know that catalyst, what is the role of the catalyst? It will help to help the reaction to be faster, okay, or it will speed up the rate of the reaction without undergoing any chemical change. So this is the role of the catalyst. So hydrogen and oxygen, they do not react with each other at room temperature, but in the presence of platinum as a catalyst, they will react vigorously. Okay, so hydrogen and oxygen, they do not react with each other. Okay, why? They do not react because they are both this gases. Okay, and gases do not react with each other at room temperature. So there should be a specific condition. But in the presence of catalyst, okay, if you take a platinum catalyst, then they will react vigorously. So this is the rule of the catalyst. Then temperature, what happens to the temperature? With increase in the temperature, the rate of the reaction also increases. Okay, as the temperature increases, what will happen to the rate of the chemical reaction? That also increases. So the rate of reaction for almost the chemical reactions, it becomes almost double for every 10-degree rise in temperature. So if you increase the temperature by 10-degree rise of temperature, okay, what will happen to the rate of reaction? It becomes double. So for every 10-degree rise in temperature, rate of the reaction goes on doubling. Okay, so this is the effect of your temperature. So these are the four important factors, okay, on which the rate of the reaction depends. First is the concentration of the reactant, second is the temperature, third is the catalyst, and the fourth is the nature of reactant. Okay. Okay. So let us see next one. Next is the order of reaction. Next is what? Order of reaction. Very important. How to calculate the order of reaction? Okay, order of reaction. Very important. What is order of reaction? Mark this as important concept in chemical kinetics. So what is order of reaction? It is defined as the sum of powers, the sum of powers of the concentration terms of the concentration terms of the reactant of the reactants in an in an in an experimentally experimentally determined rate expression. Okay, this is your order of reaction. So what is order of reaction? It is defined as the sum of the powers of the concentration terms of the reactants in an experimentally determined rate expression. So this is the definition of order of reaction. This is the definition of order of reaction. Consider, okay, let us consider a reaction. So let us consider a reaction AA plus BB giving you product. Okay, so we are considering a reaction. So what is the experimental rate expression? So the rate expression can be, the rate expression is, what is rate expression? So rate is equal to K into A raised to X and B raised to Y, right? So what is X and Y? X and Y may or may not be equal to the psychometric coefficient. Okay, so X and Y are what? X and Y are so these are the exponents. Okay, these are the exponents which may or may not be equal to the psychometric coefficient A and B of the reactant. Okay, so A and B are the psychometric ratio of the reaction. So this X and Y, these are the exponents which may or may not be equal to the psychometric coefficient of the reactants. Okay, so next, so what is the order of reaction now? So by definition, what is the definition of order of reaction? That is the sum of the powers of concentration terms. Okay, that is the sum of the powers of the concentration terms of the reactants in an experimentally determined rate expression. So by definition, what is order of reaction? Order of reaction is given as sum of the power. So what is the power? X and Y. So let us take X plus Y, right? We are taking the sum of the powers of the concentration, right, in the reactant. So what is the power? X and Y. Then what is the order of reaction? Yes, therefore, order of reaction is with respect to A. So order of reaction with respect to A is X and with respect to B is Y. Okay, so order of reaction, this is with respect to this general equation. So the order of reaction, it can be 0, 1, 2, 3, etc. Or it can be even a fractional value. Okay, it can also be a fractional value. So this is about order of reaction. So these things you have to keep in mind. Okay, so what is order of reaction? The sum of the powers of the concentration terms of the reactant. So if you consider this reaction, so this is a rate equation. So order of reaction is the sum of the concentration. So powers, right? So X plus Y. So what is the order of A is X and that of B is Y. So order of reaction, it can be 1, 2, 3, 4. Okay. And it can be even a fractional value. Okay. So by applying this, let us calculate the overall order of the reaction. Okay. So I'll give you some of the rate equations. So by seeing the rate equations, okay, you have to tell me the calculate the order of reaction. So A by 1 by half, B into 3 by 2. So tell me how to calculate. Yes, first one. What is the answer for first one? This is the second one. K is equals to A into 3 by 2, B into minus 1. Yes, calculate. Yes. So what is the order of reaction? Above reaction. So order of reaction is what? It is the concentration of raised to, right? So this you have to calculate, right? You have to calculate, you have to take this. So it is the sum of the powers. It is the sum of the powers. So what it is? What it is? Yes, it is 2. Okay, it is 2. 1 by, no, 1 by, not 1 by half. See here, I'll show you again. See here, what is the question here? Okay, so they have given a rate equation A raised to 1 by, okay, and B raised to 3 by 2. What is rate equation? This is rate equation. So what is order of reaction? It is the sum of the exponential. Okay. So the sum of the powers of the concentration terms of the reactants. Right. So what is the power? So it is order of reaction is. So you have to take the sum of these powers. So it is half plus 3 by 2. So to take the common this LCM, so it is 2. Okay, so take the common, so it is 2. Okay, then 1 ones are 2 ones are 2 and 2 ones are 2. So 1 ones are plus 3 ones are. So it is 4 by 2. So that is equal to 2. So the order of reaction is 2. Now second one, calculate for second now. Order of reaction. Order of reaction. Yes, anybody? Okay, 2.5. Let's see. So this minus 1. Okay, if you take the common, so it will be 2. So 2 ones are, and this is 1, 1 twos are. So 3 ones are, and this is 1 twos are. So it is 1 by 2. It is half. Okay, it is half. Yes, second one is half. Very good. Yes, yes. Okay. It is half or it is 0.5. Got it now? So like this, you have to find the order of reaction. Very important. Okay. So the question will be given. You have to, they will give you a rate law equation and you have to find the order of the reaction. Okay. Shivaruni, did you understand? Yes. Yes. Okay. Good. So next is, so this is very important. So next is units of rate constant. So let us see the units of rate constant. So what is rate constant? It is denoted by K. So what is the unit of rate constant? If we consider AA plus BB giving you product. So if you consider this particular reaction, what is the experimental rate equation? So the experimental rate equation is what? It is rate is equals to K A raised to X and B raised to Y. Therefore, order of reaction is what? X plus Y is equals to something. Okay. Maybe N. Now, K is equals to what is K? K is equals to, we are finding the order of K. So K is equals to, let us take rate here, and it will be 10x2 and B raised to Y. So K is equals to, what is rate? Rate is what? Concentration. Okay, change in concentration with respect to time. Okay, and into so the since so A and B is also concentration. Okay, and X plus Y is N. Right. So let us see what is concentration. Concentration is nothing but mole per liter. Time is second. Okay, into 1. What is concentration again? Mole per liter into N. So what is K? Constant K is equals to mole per liter. Okay, and 1 by N second per second. So 10 mole per liter, okay, per liter minus, or that is 1 by N second. So this is per second. So this is the rate of the reaction. Okay, this is the rate of the reaction. Okay. Now, this order of reaction, it can be for your syllabus, you have 3 orders of reaction. Okay, so the firstly, it is zero order. Secondly, the reaction, what you're going to learn is first order, and then is second order reaction. So order will be in zero order, it will be n is equals to 0. In first order, it is n is equals to 1. In second order, it is n is equals to 2. So the units is for zero order, it is K is equals to mole per liter per second. Then for first order, it is K is equals to only per second, and for second order it is mole per mole liter per second. Okay, so very important. So remember the units of first order, second order, and zero order reaction. Okay, very important. So suppose they can give you, so they'll give you like this, and they'll tell you, tell me the order of the reaction. So what is the order of this reaction? What is this order of the reaction? By what you have to see, you have to see the units, because we know now, yes, it is a second order reaction. Yes, very good. So you can see what is the unit. So you have to remember the units. Okay, so liter per mole per second is nothing but your second order reaction. So this is a second order reaction. If they give you K is equals to 3 into 10 raised to minus 4 per minute. So what is the order of this reaction? It is a, what is it? It is a first order reaction. Very good. Okay, so it is a first order reaction. So did you understand what are the factors the effect rate of reaction? And we have discussed about the order of reaction, how to calculate the order of reaction. Okay, we have seen how to, so what are the units of the rate constants, right? Is it clear? So next is molecularity of reaction. So molecularity of what is molecularity of reaction. So let us see. Next is molecularity of reaction. So whenever a reaction is taking place in only one step. Okay, some reaction they take place in only one step. So such reactions they are called as elementary reaction. Okay, one step reactions. When the reactions takes place in one step, they are called as what? Elementary reaction. Okay, and sometimes a reaction proceeds more than one step. Okay, more than one step. So sometimes the reaction undergoes more than one step. Then such reactions are called as what? Complex reactions. What they are called as? Complex reactions, right? So the and whenever so in this complex reaction what happens, the steps, various steps will undergo, right? Then so the various steps of the complex reaction, it is called as the mechanism of reaction. So whenever there is a reaction in which there is more than one step, and this one step reaction, okay, well, that is more than one step reactions, various steps of the reaction, it can be explained in called as the mechanism of the reaction. Now, whenever we are seeing the mechanism, okay, whenever now we have seen haloalkanes, haloarenes, right? In haloalkanes, haloarenes, we have seen SN1 and SN2 mechanism. SN1 was what? SN1 was two-step reaction, right? In two-step reaction. SN2 was what? It is a one-step reaction, right? Now, in SN1 reaction, okay, we could see that how the various steps were explained, how by writing its mechanism. So we know that, so one step in SN1 mechanism where there is various steps involved, okay. So there will be, one will be a slow step, another will be a fast step. So whenever a slow step is undergoing, so this slow step will decide the rate of reaction. Okay, rate of overall reaction will be decided by the slow step. So we have seen in SN1 reaction, right? Two steps were there. First was the slow step, second was the fast step. Slow step was what? Formation of carbocation, right? And this slow step was the rate determining step. Okay, it is called as what? Whenever a reaction, okay, when there is more than one step, so the slow step will be there. So this slow step will explain the overall rate of the reaction, and it is called as the rate determining state, or it is called as the rate controlling step. Okay, and the order of reaction, it is determined by the slowest step. So whenever you are calculating experimentally the order of reaction, it is determined of which is undergoing a slow step. Suppose if we and if you take example of decomposition of H2O2, that is your hydrogen peroxide in the alkaline medium. So how this hydrogen peroxide will undergo decomposition to give you H2O and oxygen. Okay, so what is the mechanism for this reaction? So the mechanism, so one will, so there will be two steps. So step one is what? H2O2 will react with I minus to giving you H2O plus IO minus. Then second step is what? In second step, your H2O2 will again react with the IO minus, okay, which is found in the first step, and you get H2O plus O2 plus I minus. So this I minus get cancelled, IO minus get cancelled. And when you write the overall reaction, it will be H2O2. Okay, so 2H2O2 because 1 and 1, so 2H2O2 giving you H2O, 2H2O plus O2. So this is the overall reaction. Now when we see the rate of the reaction, so rate of the reaction is determined by the slowest step. Which is the slow step? First step is the slow step, second step is the fast step. So in the slow step, the rate of the reaction depends on the concentration of the reactant as well as the product. So it is H2O2 as well as the rate of the nucleophile, that is I minus. Okay. So the concentration is raised to 1. So the order of reaction is 1 plus 1 is equals to 2. So the order of reaction is determined by the slow step. So H2O2, there is no stoichiometric coefficient. So it is taken as 1. In I minus, that is your nucleophile. So that is also, there is no any stoichiometric ratio. So it is taken as 1. So will, so we are adding this one coefficient and we get what? 2. Okay, we get 2. So this is the molecularity of reaction. So molecularity of reaction is different, and the order of reaction is different. So what is molecular reactivity? It is a number of reacting species, okay, taking part in an elementary reaction. Okay, and this must collide simultaneously in order to bring about a chemical reaction. So such reactions, they are called as molecularity of reaction. So order of reaction is different and molecularity of reaction is different. So the other things related to molecularity of reaction, so let us discuss it in the next class. Is it clear? So molecularity of reaction, will take some more examples in the next class. Okay, then your doubts will be clear. Fine. So order of reaction, is it clear? Yes, is it clear up to order of reaction? Yes. Okay, fine. So molecularity of reaction. So we have seen the basic. Okay. So let us see some of the example in the next class. Okay. Fine. So any doubts up to here? Okay. Fine. So yes. Anything you want to ask? Yes. Any doubts? Anything you want to ask? Did you go through the notes of alcohol, phenols, and ethers? Anything you want to ask? Any doubts? Okay. Fine. Okay, so yes, we will decide about unit test soon. Okay, and we'll let you know. Fine. Okay. So, so the next thing, okay, molecularity and the other things. So we'll be discussing in the next. Okay, so Monday's class. Okay, so have a good weekend. Okay, so we'll end it here. So we'll meet on Monday. Thank you. Thank you, dear students.